So our next topic is symbolic reasoning under uncertainty. Mathematical reasoning enjoys a property called monotonicity. We have seen in the previous class that if we are having some premises, we can make out some conclusions. So if this premises is being enlarged or expanded by addition of some more premises, then if our conclusion doesn't change, because this set of premises that we have considered for reaching into a conclusion remains as it is in a bigger number of premises, then the conclusion stays as it is called as monotonic. So by the addition of new premises, our old conclusion does not change, is called as monotonic. If it changes, we call it as non-monotonic. So human reasoning is non-monotonic because we are always arriving to some conclusions only tentatively. Based on some partial or incomplete information, we will be making some decision, and we have the liberty to change that decision when new information is arrived. So that is the human being's nature of making decisions. We will be making decisions tentatively, not a permanent decision. Means we have the liberty to alter the decision as and when new information comes in, because the new information is against our old decision. So we have to change that decision. That is known as non-monotonic. The reasoning in artificial intelligence are divided into various ways, because reasoning means it is the mental process of deriving logical conclusions and making predictions from available knowledge. The knowledge can be facts or beliefs, and we can say that reasoning is a way to infer facts from existing data. We have seen this before, and it is a general process of thinking rationally to find valid conclusions. So in AI, the reasoning is essential so that the machines can also think rationally as a human brain and can perform like human. For that, we have different types of reasoning. They are deductive reasoning, inductive reasoning, abductive reasoning, common sense reasoning, monotonic reasoning, and non-monotonic reasoning. Let us see them one by one. The inductive and deductive reasoning are being used with propositional logic. And deductive reasoning we have seen in the last class in natural deductions. We will be deducing new information from logically related known information. If we are having some premises, from that we will be arriving into some conclusions. It is the form of valid reasoning, which means the argument's conclusion must be true when the premises are true. That is what we have seen in the last class. Whenever the premises are true, the conclusion is also true. The deductive reasoning is a type of propositional logic in artificial intelligence. It requires various rules and facts. It is sometimes referred to as top-down reasoning, and it is the just opposite of inductive reasoning. So here in deductive reasoning, the truth of the premises is guaranteed by the truthness of the conclusion. For example, we have a premise such as all the human eats veggies. That is premise A. Then premise B is Suresh is human. From these two premises, we can make out a conclusion that Suresh eats veggies. Is it not? From premises 1, we have all the human eats veggies and Suresh is a human. Then we can conclude that Suresh eats veggies. So in this type of reasoning, we travel from theory and make out some hypothesis and find some patterns from that, and we will conclude a confirmation. This is the general process of deductive reasoning. Then we have its opposite version, which is inductive reasoning. It's a form of reasoning to arrive at a conclusion using limited sets of facts. We will be having only limited set of facts, and we will be assuming we will be going with probability for some generalization. So it starts with a series of specific facts or data and reaches to a general statement or conclusion. It is a type of propositional logic which is also known as cause-effect reasoning or bottom-up reasoning. Here we use historical data or various premises to generate a generic rule. Let's see an example. When we go to a zoo, we see some pigeons, and it happens to be white in color. All the pigeons we saw in the zoo happens to be white in color. Therefore, we are making a conclusion that we can expect all the pigeons to be white, because we have not seen any pigeons of a different color, and we are assuming or generalizing the fact that all the pigeons are white in color. So from observation, we will be making some pattern, and from that pattern we arrive at hypothesis. From there we conclude to a theoretical statement. So this is inductive reasoning. Then we have abductive reasoning. It's a form of logical reasoning which starts with single or multiple observations, then seeks to find the most likely explanation or conclusion for the observation. Example, we have a statement: cricket ground is wet if it is raining. A playing ground is wet if it is raining. And we have the fact that the ground is wet, and from these two we are making out that it is raining. So this may not be true, our conclusion may not be true in this case, but from the available facts we are making out some conclusion. Then we have common sense reasoning. Most of us do common sense reasoning. It is based on experience. It is gained through experience. It simulates the human ability to make presumptions about events which occurs on every day. So a conclusion that is being taken today may not be similar when we take a decision tomorrow, because between these interval we might have acquired some more information regarding the real-time experience. So that is common sense reasoning. Let's see an example. One person can be at one place at a time. if I put my hand on fire, in a fire, then it will burn. These are all the facts which we gathered through experience. No person can be at two places or more than one place at a time, at the same time. Then if we put our hand in a fire, we will get burnt. So we don't have any proof for this, but we have gathered this information through experience. Then we come to monotonic reasoning. In monotonic reasoning, once the conclusion is taken, then it will remain the same even if we add some other information to existing information in our knowledge. So we are having some knowledge base, and with the information available in the knowledge base, we will be taking some or arriving at some conclusion, and as the time passes by, we will be adding some more information to the knowledge base, but the decision we have taken before stands as it is, because the decision was based on some premises and there is no change in those premises. Even though we have added new premises, then there will be no change in the conclusion. Such situation is called as monotonic reasoning. For example, if Earth revolves around the Sun is a premise, it's a known fact which will not be changed even if we add many premises into this knowledge that Earth revolves around the Sun. Let this be the moon revolves around the Earth, or the Earth is not round. Such information will not change our decision that Earth is revolving around the Sun. This is an example of monotonic reasoning. The advantage of monotonic reasoning is that here the old proof will always remain valid. Why? Because if we add new premises, there will be no change in the decision or proof that we have arrived at. So we can rely on the proof that we have arrived as time passes by. If we deduce some facts from available facts, then it will remain valid for always. There will be no change in the known facts even if new facts are being added to the knowledge base. That is the main advantage of monotonic reasoning. The disadvantages are we cannot represent real world scenarios using monotonic reasoning, because real world activities are dynamic in nature. As time passes by, we will be having new information which naturally affects the environment. So in that case, we will not be able to move on with monotonic reasoning, because we are not in a position to add new information that affect some situation. If we are adding new information and if there is no change in the environment, there is no point in adding new information. So in monotonic reasoning type of reasoning, we will not be able to make any changes into the conclusion that we have made by the addition of new information. So that is a disadvantage of monotonic reasoning. In non-monotonic reasoning, Some conclusions may be invalidated with the addition of new information into the knowledge base. We have made some conclusion, then by with the information that is available in the knowledge base, and by the addition of new information, the decision made has to be changed. That type of reasoning is known as non-monotonic reasoning. So it deals with incomplete and uncertain models, because when we make a decision, we are not sure that this decision will stay for long, because by the addition of new information, there is chance for changing the already made decisions. Let's see an example. We have the premises birds can fly, that is one premise. Penguins cannot fly, that is another one. Then Pitty is a bird. From these premises, we can conclude that Pitty can fly. Why? We have already stated that birds are able to fly and Pitty is a bird, so that we can conclude that Pitty can fly. But afterwards, after making this decision, we are adding one more premise saying that Pitty is a penguin. So Pitty is a bird, and if Pitty happens to be a penguin, penguins are also birds, but they cannot fly. So we are changing or reverting our conclusion by the addition of one more premise, that Pitty cannot be in a position to fly, being it is a penguin. The advantages of non-monotonic reasoning is that it can be used for real world system, because it is subject to changes as and when new informations are being inducted into the knowledge base. So that is the main advantage of non-monotonic reasoning. And the disadvantages is that old facts cannot be kept as it is with the addition of new information, because there is a chance of invalidating the old fact by adding new statements. So it cannot be used for theorem proving and so on, because they are all different. Theorem provings are all dependent on this hypothesis, which are having a permanent nature. If it is going on changing with the addition of new information, these theorems will not be static in nature. So it cannot be used for theorem proving purposes. That is the main disadvantage of non-monotonic reasoning.